Hey, welcome back to Modern Era Code. Today we're diving into TypeScript classes and objects. If you've ever felt JavaScript's object-oriented programming was a little unpredictable, luckily TypeScript can help bring some safety and structure to the table. JavaScript classes can feel a bit chaotic. Properties can be added dynamically, and you never really know what's inside of your object. Luckily, TypeScript can enforce some structure, ensuring your object behaves exactly the way you would expect. In this video, we'll explore how to define, extend, and protect class properties in TypeScript. In JavaScript, classes were actually introduced with ES6, but they didn't, and they still don't, enforce types. With TypeScript, we can enforce types right off the bat, making your code much safer. For example, if we wanted to declare a new class in TypeScript, it would look something like this. Here we have a car class with a constructor that takes three parameters: make, model, and year. Each parameter has their respective type. Make should be of type string, model should be of type string, and year should be of type number. And we also have this display info function that we're saying should return a value of string. Now, if we want to use this class, we can do so like this: const myCar equals new car. Now this expects three parameters because they're in our constructor. So we're passing it the make, Lexus, the model, RX450H, and the year, 2021. We can also use this function in our class like this. We can say, in this case, console log mycar.displayInfo, and this will actually output 2021 Lexus RX450H. With TypeScript, we can instantly catch issues like missing properties or invalid data types. One of the biggest benefits of classes is actually something called inheritance. This allows us to create new classes based off of existing ones. For example, say we want to create a new class to include electric cars. We can do so like this: class electric car extends car. Now with this, the constructor takes in the same three parameters, but it also takes in a new one, battery capacity. We have an added function here, getBatteryInfo, that just returns us our battery info. We can use this class by declaring new electric car, pass it the parameters that it expects, and we can use both getBatteryInfo and displayInfo from our parent class because we are extending it. What's happening here, and why is it so powerful? Super actually calls the constructor of the parent class car. We can extend its functionality without changing anything in the parent class. This enforces code reusability and less duplication. Now we have a structured, reusable way to define new types of cars. Sometimes we don't want properties to be modified directly. In this case, we can use getters and setters to control access and enforce validation of the class properties. For example, say we have this class, car with encapsulation. We can define a getter with a get keyword and a setter with the set keyword. We have a variable here, underscore mileage. Our getter returns us the value of that mileage, and our setter sets the mileage's value to the one we pass. We can declare a new instance of this class, the same as usual, using the new keyword, and we can use our getter and setter to set and retrieve the values of the private mileage property. And we get the added benefit of the validation in our setter. So if we try to set this to an invalid value, we'll actually throw this error. Encapsulation protects the internal data from unintended modifications. Validation ensures only valid values are assigned. Readability makes accessing and modifying data more intuitive. This pattern keeps our data safe and our code predictable. We can define structured objects, extend them with inheritance, and control data access with getters and setters. Next up, we'll take TypeScript to the next level and dive into generics, the key to writing reusable, scalable, and type-safe code. Make sure to like and subscribe so you don't miss it. I'll see you there.